Hello friends, welcome to this channel. This is G Solutions, where we find solutions for your needs. Today we are to solve sample problem wherein the resistor and capacitor are in parallel. And we are to use the knowledge or the concept of the functions with respect to the time. Okay, so let's have this problem. So it says here, find the total current to the parallel circuit of a 20 ohm resistor and a 15 microfarad capacitor with an applied voltage of B is equals to 100 sine 2000 t V. So in our drawing, the resistor and capacitor here are in parallel. Okay, so this is also the supply. Again, our resistor is 20 ohms and the capacitor is 15 microfarad, and our voltage supply here is 100 sine 2000 t volts. So you are tasked, or we are tasked, to find the total current. So what will be the total current here? I sub t. Okay, so to get I sub t, so I sub t. Okay, so let us know that the current that it will be in this branch are by using Ohm's law, the voltage at this branch, considering the element in this branch, which is the resistor, and also another current here. Let's say this is I sub C. So that will be, if we will name this as I sub R, okay, that will be added to I sub C. Okay, so that's it. So what is the value of your I sub R? Actually, our I sub R is the voltage here, which is 100 sine 2000 V divided by the resistor by Ohm's law. So that will be 100, okay, sine 2000 t over 20. That will be your I sub R. And for your I sub C, okay, so plus, so you have to convert this to X sub C, and X sub C is actually 1 over omega C. Okay, so what is your omega? Our omega is actually 2000. So we know that our omega here is 2000. So therefore, this is 2000, okay, and multiplied by 15 microfarad. So we convert this to farad, so that will be multiplied to the 10 raised to negative 6. So this will now be 1 farad. So this is 1 omega C. Okay, and therefore the voltage I sub C, the current I sub C is, by Ohm's law, is the voltage 100 over X sub C, which is 2000 times 15 times 10 to the negative 6. Okay, and this is multiplied by sine 2000 t. Okay, so but since this is capacitive reactance, if we will introduce here sine 2000t, we also have to add a 90-degree angle in our sine here in the numerator, because this is capacitive reactance. Okay, so therefore we can now simplify. So 100 divided by 20, it will give us 5, and then I'll copy sine 2000t, and this one plus, you have 100 divided by 2000 divided by 15 times 10 raised to the negative 6. If you have your calculator for that, you just press your calculator and it will give you 3. Okay, and copy sine again 2000t, but since this is a capacitive reactance, so you add here plus 90 degree. Okay, so therefore we can still expand this one. So you have 5 sine 2000t plus 3, okay, sine, using now the trigonometric identity for the angle, two angles, sine AB. So let me just be reminded by this trigonometric identity that sine A plus B is sine A cos sine B plus cosine A sine B. Okay, so this is the trigonometric identity that we will apply here. So our A here will be 2000t and your B will be 90 degree. So you have sine 2000t and then cosine 90 degree plus cosine 2000t and then sine 90 degree. Okay, so for further simplification, cosine 90 degree is actually 0. So this is 0. So you multiply sine 2000 and 3, it will give us a 0. And sine 90 degree is 1. So what remains here, by the way, let me just place here a open and close parenthesis for 3 will be distributed here. So 3, what remains here is this term. So our answer will be 5 sine 2000t plus 3 cosine 2000t. Okay, so we have now this form. The form now that we have here is the form A sine omega t plus B cosine omega t. Okay, in which A and B can be represented here in a right triangle. Okay, so our A and B, that will be now in a right triangle. So this will be our B and this is our A, and this is the hypotenuse C. This is theta. Okay, so therefore if here B is equals to 3 and A is equals to 5, and by having the Pythagorean theorem for this, you know that C is square root of 34. So because that is 9 squared plus 25 squared, you add the the 2, and then you square it, and you have square root of 34. Okay, 25 plus 9, that is 34, so square root of 34. Okay, so therefore our I sub t can be written also. We have this form where we introduce 1, which is equals to c over c. If you remember that, so that is c, actually that is a over c and sine omega t, okay, plus b over c, that is cosine omega t. So this is the form that we are considering. So therefore, if we are going to substitute these values here, we can have square root of 34 for our c, and we have also for our a is 5 over the hypotenuse square root of 34 sine omega t, or 2000 t, plus again b is 3, and c is square root of 34. You have cosine 2000 t. Okay, and you are going to note that this is 5 over 34. 5 over 34 is actually the cosine of theta. So cosine of theta is actually a over c, and sine theta is actually b over c. So what is your theta? So our theta is taking the value of b and a, that is actually the inverse tangent of 3, 5. Okay, so if you have your calculator here, so let's have the inverse tangent. That is inverse tangent there, you see, of 3 divided by 5 will give us 30.96. Okay, so this is 30.96 degree. So therefore we can write it here. Okay, square root of 34, instead of having it 5 divided by square root of 34, okay, that is a over c, and that is actually cosine theta, or cosine theta. And what is theta? That is 30.96 degree. So sine 2000 t plus 3 over 34, that is 3 over 34, actually that is sine theta. So that is sine 30.96 degree. And you copy cosine 2000 t. Okay, now let us distribute this one and have the value in the form. We are now having the form of sine omega t plus theta. Okay, so since this is of the identity, this one we here, so we have a as our 2000 t and b as our 30.96 in this case. So we can write it here as sine a plus b. So you can write it here, sine, what is our a? 2000 t. Okay, 2000 t, and our b is 30.96 degree. Okay, and the square root of 34 is equals to 5.83. So 5.83. Okay, so this will be our form. Okay, this will be the value for the total current parallel, wherein the resistor and the capacitor are in parallel. So this will be our answer. This is the total current. So I do hope I have added learning to your learning desire. Thank you so much for watching this video.